Alright guys, so in this video today we're going to be finding an angle using trigonometry. So previously we've used one side length and an angle to find the value of another side. Now we're going to be using two side lengths to find an angle. So first of all, and the way we do that is just by using these inverse sine, inverse cosine and inverse tangent functions in your CAS. Okay, so I'll go through them in detail here in some examples. So first of all, we have sine of an angle equals 0.5. Okay, if we were to rewrite, if we were going to try to find the angle, all we need to write is angle equals sine 0.5. Okay, and then on the CAS, let's do that. So follow along with me if you've got your CAS. We're going to get a scratch pad. And then trig, and notice here you have sine -1, cos -1, tan -1 there, just beneath the sine, cos and tan. So we're going to use sine -1 this time, and 0.5, and press enter, and that equals 30. And we just need to make sure that our CAS is in degrees, not radians. Okay, so make sure it's in degrees. So that's 30, and that's 30 degrees. Okay, so a little degree symbol there as well. All right, so first few ones we'll do here, we'll just practice using the CAS. So tan of an angle equals 1.192. So we just write angle equals tan -1, 1.192. That's all the working out we need to do, okay, for these ones. And then we just type that into the CAS. So we go to the tan -1 function, and then 1.192. Press enter, and that's 50 degrees. All right, let's get down to some actual some right-angled triangles. So first step, as we've done before, that we need to do with our triangles, with Pythagoras and with trigonometry. Mainly trigonometry actually, is we need to label the sides of the triangle. So we label the longest side, which is opposite the right angle. We label that as H. Now the side that's opposite the angle is going to be labeled O, which is this one over here. And then the side that's adjacent the angle is going to be labeled A for adjacent. So we're interested this time in the adjacent side and the hypotenuse. So remembering SOHCAHTOA. All right, we're going to be using ka this time for that. So we can write out the trig ratio. Cos of an angle is A divided by H. Okay, and we can write cos angle, substitute those values in, so 19 divided by 26. And now we just want to just say angle equals, so we write angle is cos -1, 19 divided by 26. All right, and then in the CAS we just find cos -1, 19 divided by 26. Press enter. And now it'll come up with the exact value there. So we press Control Enter to get a decimal. So that's 43 degrees. 43.05 degrees, 2 decimal places. Okay, we'll try one more. I'll just move this one down. So again, labeling our sides first. So the side that's opposite the right angle is going to be our hypotenuse. Side that's opposite the angle is over here, the 13, and that's going to be our opposite side. And the side that's adjacent our right angle, but not the hypotenuse, is going to be labeled A for adjacent. In this problem, we're concerned only with the adjacent side and the opposite side. So from SOHCAHTOA, we know that that's tan we want. So we want tan of an angle is O divided by A. And then substitute those values. So tan angle 13 divided by 9. And then we just write angle on its own equals tan -1, 13 divided by 9. And then in the cas, we go tan, inverse tan, 13 divided by 9, and enter. Now that's given us a pretty messy looking answer, so we want to go Control Enter to get that as a decimal. And that's our answer there, 55.30 degrees. And that's it to find, that's how we find an angle using trigonometry in right angle triangles.